Simplifying complex fractions. So what we looked at last week, or the last 2 days last week, was addition and subtraction, adding fractions, these rational expressions together, or subtracting them from each other. And we had to make the denominators be the same so that we could add or subtract. Now there's two methods with simplifying complex fractions. When we talk about complex fractions, we're talking about having fractions in fractions. Now, method one is, if necessary, simplify the numerator and denominator by writing them as a single fraction, then dividing the reciprocal of the denominator, divided by multiplying the reciprocal. And that's what we're going to look at first. We're going to look at method one first, and then we'll do method two second. And most likely, if I were a betting man, you're going to like method two over method one. Now, if we look at method two, method one states is that we simplify the numerator and denominator first. So when we look at this here, we've got a fraction on top and a fraction on bottom. Well, actually, we have two fractions on bottom. And method one states that whenever we have these complex fractions, that we need to simplify the numerator and denominator to be only one fraction. So when we look at this here, well, the numerator is, this here is one fraction. However, the denominator is, well, two fractions. So what we have to do is we have to rewrite the bottom, the denominator, as a single fraction. Unfortunately, no. Because since the x plus 4 on bottom is being added, it's not as easy as doing that. We might be able to do that eventually, but we can't do it at this point here. Now, what we're really looking at first is the denominator, 1 over x plus 4 plus 2 over x. Now, what we need to be able to do is we need to be able to add these two together. We need to add these two together. And well, to be able to add these two together, we need the denominators to be the same. So I'm going to multiply the left on top and bottom by something, and the right on top and bottom by something. Well, as we went over on Friday, it's kind of looking at the left one here. What does the denominator of this fraction have that this one doesn't? Well, x plus 4. Because we're doing just the bottom, because we can do this. Because really, x plus 4 over x plus 4 is what? 1, so we're just multiplying it by 1. It's not really changing anything. Now, if we go the other direction, what does this one have that this one doesn't? The x. Now, if we do this multiplication, so the left one, x times 1 would be x. On the bottom, we're just going to have x times now on top. Yes. Because we're going to distribute the 2 through. So 2 times x plus 4, well, 2 times x gives us 2x. 2 times 4 gives us 8. Any questions on this here? Are we good with this here so far, yes? Okay. Now what we can do is we can add the denominators. Well, we still have 5 over x plus 4. So on bottom, we have x plus 2x would be what? 3x plus 8 over x times x plus 4. So we just were able to add those numerators together. Now, what are we really doing with the numerator and denominator? Because we have 1 and 1 now. Yes, I have one fraction on top, I have one fraction on bottom, yes? Well, they're what? They're being divided, yes? So really, what we're saying, don't need a highlighter, is that I have 5 over x plus 4 divided by 3x plus 8 over x times x plus 4. Because this is really what we're doing, yes? Because we're dividing these two here. Well, if we're dividing two things, we're dividing two fractions, we never really divide two fractions. We do what? We multiply. We change it from division to multiplication and flip the second. Yes. Because for multiplication, because it's easier just to draw a bar instead of rewriting it out, we're really saying that these two are being multiplied together. Tops are being multiplied, bottoms are being multiplied. And as y'all just said, well, we can simplify the x plus 4 on top and bottom. And if I do that, what am I left with? 5x, because they are being multiplied. And what can x not be? Negative 4, because the one that's simplified out of the denominator is this here. Okay. We're going to look at method number 2 now. Now, method 2 is, again, as I said already, I think you'll enjoy method 2 a little bit more than method 1. It works a little bit easier. I had a feeling I needed to look that up, because first, what they're going to say also for this one here, for restrictions, because we know x cannot equal negative 4, yes? They're also going to talk about this one here, saying x cannot be 0, looking back at the original problem. So the restrictions are really going to be coming from the beginning, and I had a feeling that that was going to be the case. That's why I wanted to make sure and look it up. Well, so for this one here, we can really just start off with the restrictions, because these three spots here cannot be 0. So we know x cannot be what? Bless you. 2 and 0. Because if x is 2, well, x minus 2 would become 0. And for our 2 over x, where x by itself, well, it can't be 0. So those would really be our restrictions, and that's not too bad to take care of. Now, okay, apparently I'm just going to draw. Okay. So as y'all notice, method 1 wasn't too bad, because we were adding the fractions on top and bottom together, yes? So for here, we would just add the one on bottom. Now, not too bad, not too bad. That's not nice, this one here, trying to add the bottom fractions together. Let's see, come on. Oh, that's not as nice. How about this one? So it's still possible, but... So let's look at this here. Now the other way is looking to see, how can I simplify the numbers on top and bottom, the fractions on top and bottom? So what could I multiply the numerator by, or the fraction in the numerator by, to get the denominator to simplify? So what can I multiply this by to get the denominator to cancel out? Oh, what's on bottom? So what would I multiply this to cancel out the denominator? X minus 2. Because if I multiply by x minus 2, the denominator on top and bottom would cancel, yes? So what about the 2 down here? Well, x minus 2 and? So looking at this here, really, we can look at it that way. Or what is the least common denominator of top and bottom? Well, x times x minus 2. That's the least common denominator, yes? So what we can do is I'm going to multiply the top and bottom of this fraction by the least common denominator. And let's see what happens. So if I do this, and I'm going to rewrite it all out, on top, well, we're going to multiply. This is all multiplied by the 6, because it always multiplies by the top of the fraction. So I'd have 6x times x minus 2 over x minus 2, because we multiply by the top of that fraction. Now in the denominator, our first fraction, again, this is going to multiply by the numerator, which is just 1, yes? It'll be x times x minus 2 over x minus 2. Plus, well, again, this is going to multiply by our 3, which would give us what? Well, 3x times x minus 2. And this here would just be... And we'll multiply through and simplify this here in a minute, but I want to leave it in this form for now. Something really nice is about to happen. So we good with this here so far. Looking at the top fraction, well, what do I have? X minus 2 over x minus 2, yes? These would cancel out. How about on bottom? Well, these would cancel out, yes? And this 1x and this 1x would simplify out, yes? So let's see what I have left over. Well, in the numerator, I just have 6x, yes? Let's see what happens in the denominator. Well, the first one, I just have x plus 3 times x minus 2. Wait a minute, what happened to the fractions in the top and bottom? They're gone. We simplified them out, yes? Now we just need to simplify this here, because I can't leave it as x times 3 times x minus 2. X plus 3 times x minus 2. Can't leave it like that, so we'll need to simplify a little bit. Well, 3 times x is, 3 times negative 2 is, x plus 3x is minus 6. Are we done? So, yes, I agree, because I can see here that 4x minus 6 does have a greatest common factor of, so I can factor it out. Leave us with x, it'll leave us with 2x minus 3. Well, hey, 6 and 2 have a greatest common factor of, so I'll leave us with 3x on top and 2x minus 3 on bottom, because this will become 1 and this would become 3. Yep. Now he said x cannot be 2. Yep. 2 or 0. Do we have another one that we need? Yes. So we need this 2x minus 3, yes? So 2x minus 3 equals 0, because it can't be zeros. So we set it equal to 0 to find it. So the first thing we would do is to add 3. And then divide by 2, which will tell us x is equal to 3/2, so really x cannot be 3/2. Yep. That was one more interjection, I thought. Yep. So this here, we had to add another one because the 2x minus 3 came up in the solution. and it would be another value of x. At this point, that would cause this to equal 0. So what do we think? Do we like method 1 or 2 better? 2, it's a little bit easier. For number 2? Mm-hmm. So if we look at this here, we want to find kind of the least common denominator. Because if I can find this, then I can use that to simplify the fractions. Now, there are other numbers we can multiply that would work, but the least common denominator is the smallest one that works. So we're trying to find what number I could multiply each one of these fractions on top and bottom by, and get the fraction to simplify out completely. Essentially get the number that we multiplied to simplify out with the number on bottom. Now we're looking at 6, 3, 5, and n, and we're trying to figure out what the number is. Now, because one of them is 10, we know that the ones digit has to end in what? There has to be what value? Could it be 9?
Oh, wait, it has to end in 0. No.
Yeah, it has to end in a 0 because if 10 is a factor of it, it has to end in a 0. Otherwise, it won't simplify with 10. So that's kind of nice because we know it has to be some number with a 0. So something 0.
The first one, all of them would reach 30.
Yes. The first number that all of these would reach to would be 30. It might be tempting to say 60 because 3 is divisible by 6, so 60 would work for 6, 3, 5, and 10. But 30 is a smaller number that works also, and it's the first one. Now, if you use 60, that's fine, but you will have a greatest common factor of 2 that you are guaranteed to have to pull out later. So we can use 30. We're going to multiply top and bottom of this fraction by 30. And if we do this here, so we're multiplying each numerator of each of the fractions in the numerator by 30. Well, 30 times x would be 30x over 6. 30 times x would be 30x over 3. We'll do the same thing with the denominator. 30 times x would be 30x over 5 minus, well, 30 times 70, or 7, is 210. Mm-hmm. You're good.
Denominators on bottom and top, the exact what they are, so 5 times 6 is 30.
Mm-hmm. 5 times 6 and 3 times 10.
I thought that would be.
It is, and it looks like it'll work here, but it might not work every single time. Because if for some reason they said negative, or x over 3 plus x over 6, then it wouldn't work as well. You'd have to cross it. So there are ways to get to it that way, but it may work, it may not. Now let's simplify. Well, 30 divided by 6 would be what? And we have our x still, minus. 30x divided by 3 would be negative, or 10x, and they are being subtracted. 30x divided by 5. And 210 divided by 10. So let's see here. So the numerator is 5x minus 10x would be negative x. Well, 6x minus 21, we can't combine those, but there is a greatest common factor of 3. We can pull that out, leaving us with 3 times x minus 7. Well, that's as simplified as it gets because 5, well, negative 5 and 3 do not have any greatest common factors because they are prime. And there's nothing else in common on top and bottom.
I thought it would be 2x.
Yes, it would be. Thank you. It would be 2x minus 7. Thank you.
Oh, yes.
Yeah. Yeah, I don't know why, but I've done that the second time today. I keep trying to factor it out completely when it doesn't. Now we need to look at the restrictions. So is there anything that'll make the denominators of any of these fractions equal 0? I mean, well, can I plug a number into 6 to make it 0? Well, there's no number, I mean, 6, 3, 5, and 10, there's no place for me to plug in a 0 to make it 0.
No.
So it's not going to list any for this here. I mean, we could technically see what value of x would make x over 5 be the same as 7 over 10 and go from there. Because for that to be the case, it would be 2/7. Because 2/7 divided by 5 would give us 7/10. But it doesn't ask for any here. And it also would be a restriction for this denominator. But as it's looking, it's really just wanting the restrictions for the start.
We don't
Yes.
Okay.
Yes, because on the first one, they only listed -4 and 0. They did not list -8/3. Well, we ended up at the end. Right, so this one here, well, x cannot be 0 because of our 2 over x and our 4 over x. Or our 2 over x and 2 over x on top and bottom. And that's the only one that we're going to list. Okay. Tricky one here. What would be the least common denominator between these two? Least common denominator between these two.
12.
The 3 and 4, do they have a denominator? So we're going to need something a little bit different than 1. What has a denominator on top and bottom? The 2 over x and 2 over x. So that's the one we're going to need to simplify. We're not too worried about the 3 and 4 because they don't have a fraction in top and bottom, so we're not worried about those. We're mainly wanting to simplify the 2 over x in the numerator and the 2 over x in the denominator. Now, what do I need to multiply by 2 over x to make the x in the denominator cancel out or simplify out? It's x. Could multiplying it by 2x work? Well, yes, but I would have a common factor of 2 that would end up coming back out at the end. And for these here, so we multiply top and bottom by x. So 2x wouldn't be bad, but when we start talking about sets of parentheses,
Right.
it's going to make it a little bit harder. Okay. Any questions on this here? Okay, so we're going to multiply through the numerator by x. So we'll multiply the 2 by x. So we'll have 2x over x minus 4x. We'll do the same thing in the denominator. We'll have 2x over x plus 3x. That very much looks like a v. Okay. Well, what can we do? Well, these cancel out, leaving us with what? I'm going to say negative 4x plus 2. That's just the mathematician in me, because I always want to put the variable first, even if it is negative. And in the denominator, it would be 3x plus 2. Yes? We can factor a negative 2 out of the numerator because negative 4 and 2. Well, we can factor out the negative because the x is negative, but there is a common factor of 2 between 4 and 2, which will leave us with 2x minus 1. Since we factored a negative out, the signs would change. Since the 4x was negative, it is now positive. And since the 2 was positive, it is now negative. And that's it. And our only restriction was that x cannot equal 0. Questions on this here? Any questions on any of this here so far? Bushy. We good with this here? Okay. So let's look at our restrictions first. What is going to make the denominators of the fractions equal 0? Yes. Yes. Because x minus 3, what value of x is going to make it 0? Is going to be positive 3. X plus 5, well, negative 5 plus 5 is 0, so that'll make one of the fractions be 0. It'd also be good to know the least common denominator, which would be because we're looking at what simplifies the denominators. So on top, the denominator is x plus 5. So if I multiply the top fraction, the fraction in the numerator, by x plus 5, that denominator would simplify out. The 2 in bottom, one of them is x minus 3, one of them is x plus 5. Well, if I multiply the one with x minus 3 by x minus 3, those would simplify. If I multiply the other one by x plus 5, those would simplify, yes? So our least common denominator is, well, x minus 3 times x plus 5. And we only need as many as it's going to take to simplify each of the fractions. We don't need, yes. So even though x plus 5 appears twice, one in the numerator and one in the denominator of this complex fraction, we only need it once because in each of those spots it only appears once. So on top here we're going to have 3 times x minus 3 times x plus 5 over x plus 5. In the denominator, we're going to have 2 times x minus 3 times x plus 5 all over x minus 3 plus x minus 3 times x plus 5 all over x plus 5. Now, if you don't need to rewrite these all the way out, if you can see, okay, so the numerator, the x plus 5 and x plus 5 cancel, and can go and just say, okay, well, it's just going to be 3 times x minus 3. That's fine. If you can see that and how they cancel, that's fine. You can write it, go straight to here. Because we'll distribute here in a minute. Because, and you got 3x minus 9? Yeah, that's fine. Because I'm just writing these out because I don't want to be doing too many steps all at once. On the denominators, the x minus 3 and x minus 3 would cancel here. X plus 5 and x plus 5 would cancel. Which would leave us with 2 times x plus 5 plus, well, x minus 3. Now, you might be wondering why I just went on and just dropped the parentheses around the x minus 3. Well, that's because we're adding, so no signs really change. So dropping them doesn't change anything. Now, as we said, we're going to have to distribute the 3. So 3 times x would be 3x, and 3 times negative 3 would be negative 9. 2 times x would be 2x. 2 times 5 would be plus 10, plus x minus 3. Any questions on any of this here? Everybody's saying,
Wait, why? Stuff the same. Blank out.
because we need to combine like terms.
Oh,
Because 2x plus x is,
3x.
10 minus 3 is,
Okay.
and I have a feeling the textbook's going to be a little bit picky, or Big Ideas is, because it always is. Even though it can't go anywhere, we can still factor 3 out of the numerator, because 3x and 9 have a common factor of 3. So we can factor that out, and this is what we would get. Which means we didn't actually have to multiply through the numerator anyways. So, questions on this here? Any questions on any of this so far? We feel good with this here? Yes?
More examples?
Sure. Which one do we want to look at this one here?
Yeah.
Okay. So what would we need to do to simplify this here? Or well, let's start off with our restrictions. What can A not be? Positive 2 or 0. Okay. So what do we need to multiply the numerator and denominator by to get these? Huh? A and A minus 2, yes? Mm-hmm. Yes. Well, that's what we need to multiply the top and bottom of this by to get those fractions to simplify. So if we look at the numerator, well, again, we're multiplying these by the numerator of each numerator in this complex fraction. So A times A minus 2, because we're just multiplying it by 1 over A, minus, well, here it's going to be 3A times A minus 2 over A minus 2, because again, this is multiplying by the numerators of this complex fraction. We'll do the same thing with the denominator of the numerators. So we'll have 2A times A minus 2 over A plus, and then we'd have 5A times A minus 2 over A minus 2. Questions on this here so far? Okay. So let's see what simplifies out. Well, the A and A minus 2, A and A minus 2, yes. So what that leaves us with is minus 2 minus 3A all over 2 times A minus 2 plus 5A. Now, I left the parentheses in the numerator because we were dealing with subtraction, so we've got to be careful with signs. Now, it turned out that it was just 3A, that's all that was left over, so that's not going to be too tedious because we're not having to worry about making sure the signs of everything in that second part change because it's only one term. So we can just drop them if we wanted. Because when we look at this here, we really just have A minus 3A. Well, what is A minus 3A? Negative 2A minus 2. Yes, and we'll do that here in a minute. Because we'll have to distribute this 2 first, because we'll need to simplify the denominator. Well, 2 times A is 2a. 2 times negative 2 is minus 4 plus 5a. So in the denominators, we can combine like terms. 2a and 5a would give us 7a minus 4. And yes, we could factor a negative 2 out of the numerator, which would leave us with a plus 1. And that is it here. You're good? Questions on this here? Is this here any harder than what we've been doing? A lot of steps, yes? This one's actually not in the textbook. This was straight from a college website. So this is a problem from college algebra. Well, it's not any harder than what we did, right? Now, and I mentioned this earlier, a lot of what we do in Algebra 2 is the exact same thing you'll do in college algebra. They'll just make it a little bit harder. We'll do a few more steps. Yep. But the overall process and what we did does not change. So, yep. Yep, negative 3/2. And the way we can look at that is because, well, what do we know first? We've got to move the 3 over by subtracting, and then we have to divide by 2. Now, what would be the least common denominator? What are we going to multiply the top of this fraction by and the bottom? 2x plus 3. As well, that's the only thing that's in the denominator. So we have to multiply this by each term. So I'm going to have to have x times 2x minus 3 minus 4 times 2x minus 3 plus 9 times 2x minus, or 2x plus 3 over 2x plus 3. Now, it might be tempting to go on and multiply that by 9 to the 2x plus 3 times 9, but why wouldn't we want to do that? Well, that fraction, right? The 2x plus 3 and the 2x plus 3 are going to simplify. They're going to cancel out. So there's no reason to multiply them together if we're just going to do that. Now, the denominator will have x times 2x plus 3 plus 3 times 2x plus 3 minus 5 times 2x plus 3 over 2x plus 3. Again, those will cancel. So our fractions actually simplified pretty well because the top one's going to be 9 and the bottom one's just going to be 5. But we do have to multiply everything else. So we have to multiply this by x. So 2x times x, well, that's going to be 2x plus 8x minus 12 plus 9. So we just had to go through and distribute those two numbers, and we get this here. Not yet. And then we'll do the same thing with the denominator. So we'll have 2x squared plus 3x. Do the same thing with the 3. So x plus 9 minus 5. Bless you.
They just combined thingies.
X squared. Or what part? So where was the lesson?
I'm just watching because
Okay, that's fine.
I'm lost with like the 2x plus 3x fraction.
Here, here. Where we got this?
Like the whole like plus.
Well, here we multiplied through. So the first one I did x times 2x, which gave me my 2x squared. X times 3 is negative 4 times 2x is negative 4 times 3 is, well, everything except for the 9 simplified here. And then we did the same thing with the denominator. And again, these parts canceled, leaving me with the minus 5. Well, x times 2x, 2x squared. X times 3 is 3 times 2x is 3 times 3 is, and we get our minus 5. So it's just simplifying that out there. Now our next step is we combine the like terms. The 2x squared, there's no other squares. 3x minus 8x gives us negative 5x. And negative 12 plus 9 gives us negative 3. Now the denominator, again, we have 2x squared, because there's no other x squared terms on bottom. 3x plus 6x is going to be plus 9x.
Plus 4.
Mm-hmm.
You could definitely factor
Yes.
Yes. Hey, listen, I see factoring and I can do it. I can do factoring.
Now,
You were bad about the other step.
I'm going to go on and give you the factors for this here. Because the numerator is going to be 2x plus 1 times x minus 3, and we could go through the steps that we've been doing, and you'll get to this here. The denominator will have 2x and x. It's going to be plus and plus 1 and 4.
Wait,
Hold up. Let me work out this.
2x times negative 3 would be negative 6x. X times 1 would be plus x. And here we would get,
Yeah, okay.
yeah,
I was sitting here like, wait a minute.
yeah, no, I skipped.
Factoring's the only thing I can do without help.
Yeah, now this year I skipped on through it because we're running short on time. But I know that y'all can get that eventually, and we can get to that step. And this is it here. Now this is the end of this year. I know there's more notes to it. Hold on for 1 second before you all start moving. Hold. So